Alright, we've been talking about pulse width for injectors, and I want to kind of reiterate what pulse width is and then also add some things. So we're going to talk about pulse width. We're going to talk about what a cycle is, what frequency is, and then something called duty cycle. Injectors are controlled by controlling pulse width. A lot of other things are controlled by a duty cycle. So let's start with an injector pulse width. So if this were 12 volts, and remember we're dealing with a circuit that we've got a coil wire, battery plus on one side. This would be our injector. Could be a lot of other devices. Could be a EGR solenoid. Could be a evap vent solenoid, evap purge solenoid. Could be a door lock actuator for that matter. Anyway, battery plus on one side. This side, of course, then needs to be grounded in order to get current flow through the device. In the case of an injector, of course, it's the PCM that's going to be doing that grounding. If you want to monitor activity on this circuit and see what's going on, of course, monitoring the positive side would do you no good. It's just going to be B plus all the time. I could monitor by measuring the current flow around the wire with a current probe. That actually works really well. But right now we're going to talk about monitoring the voltage, which I have to do then on the ground side to be able to see this 12 volts getting pulled to ground and then released and getting pulled to ground. So I hook up my scope like this. I do not probe across the injector. One scope lead here, one scope lead here. Don't do that. Although it could work, there is a danger. If you accidentally short your two scope leads together, your two back probing pins together, you could, you would flow way too much current through the transistor in the PCM, because then you take away all the resistance in the injector, you make a short circuit, you could fry the transistor in the PCM. It has happened, and it has happened in our shop to students that were working on a car, one time a customer car, one time a school car. Anyway, so back to our diagram, or our scope waveform. So here's our diagram, and if I were scoping right there, I would see the battery voltage coming through the injector until the PCM turns the injector on. Then I see that battery voltage getting pulled down to 0 volts to ground. And then it would stay at ground for whatever the pulse width is going to be, and let's say our pulse width in this case is 3 milliseconds. So the time from there to there until the injector turns back off is what we're talking about when we talk about pulse width. 3 milliseconds is the pulse width. Makes sense. The injector's pulse, that's the width of the pulse width of the injector, or the on time of the injector. When the injector turns off, it returns to battery voltage, but since it is a coil of wire, it spikes. We get a high voltage spike. That voltage on that spike can go as high as 120 volts. Typically the PCM will clip the spike off because inside the PCM, in parallel with the transistor, they use a Zener diode, which they call a clamping diode, which at 60 volts many times will clip that spike off to prevent that high voltage from going back into the PCM. Okay, so that is kind of a review of pulse width. Now, I'm going to draw just a square wave control. Now, we're not talking about a square wave from like a Hall effect sensor or something like that here now. Now we're talking about a solenoid that's being turned on and off, like an injector being turned on and off. And if the device is controlled pretty rapidly, there may not be enough magnetism that's released to actually create much of a spike. So let me explain what I'm talking about again. If I'm controlling a solenoid, like the fuel injector right here, and I ground that device and hold it on for, in this case, 3 milliseconds, and then release the ground, there's enough magnetism that's built up in the coil of wire during that 3 milliseconds time that when the ground is released, there's a pretty significant voltage spike. If the ground is not, or excuse me, if the magnetism never really gets released because the PCM just goes and grounds it again right away, we don't get much of a voltage spike. So this would be an example of like a EGR valve that's being pulsed on and off. If it's pulsed on and off rapidly enough, the magnetic field never really collapses. And this is something that is called duty cycle control, where it's pulsed so rapidly that the magnetic field stays in the device. So if you imagine a valve opening, if it's being pulsed on and off rapidly enough, the valve never closes. It is held in an open position, and it can be held in various open positions depending on the duty cycle. Let me explain that a little further. First of all, we have to understand what a cycle is. A cycle is where something in the waveform happened until the exact same thing happened again. You see here the voltage went from low to high. Look for when that happens again. At this point here, it went from low to high again. So if I were to put some letters on here, A, B, C, D, you know, where is a cycle? It would be from A to C, or it could be from B to D. So again, what you're looking for is, obviously I've got a high voltage right here. And when I say high voltage, I mean this is 12 volts up here, battery voltage, and 0 down here. If it went from low to high, where does that happen again? Now you might think, well, why isn't A to B a cycle? Well, because at that point it went from high to low. So it has to be the exact same thing happening. So from A to C is called a cycle. Okay, A to C would be a cycle. I crossed off B to avoid confusion there, but B to D would be a cycle. So hopefully you kind of get the idea of what a cycle is. Now, how often a device is pulsed on and off is referred to as frequency. Frequency is how often a device is pulsed on and off. Many solenoids, like an EGR solenoid, is pulsed at 128 cycles per second. Seems pretty fast, but actually that in the electronics world, that's not all that fast. That means that there's 128 of these pulses going, you know, devices off, devices on, devices off, devices on. Now you might be thinking, well, what do you mean devices on when it's 0? Remember, if we're looking at a circuit like this injector circuit, when is the circuit actually flowing current? It's when it's grounded. So when the voltage is at the ground, the low side, that's when current is flowing. So this would be on, this would be off. On, off. Okay, the cycle of on-off occurring 128 times per second, the frequency of that device is 128 hertz. The name we give to cycles per second is hertz. Cycles per second. The name for that is hertz. H-E-R-T-Z, abbreviated H-Z. So this EGR solenoid that I'm talking about here with this square wave going on, this duty cycle controlled EGR solenoid, is cycled at 128 hertz. Okay, more on duty cycle here in a minute.